Today we are going to see the topic recognition of tokens. Already in the last class we had discussed about the specification of tokens. So token will be specified using pattern. Pattern will be represented by using a regular expression. This is my outline of presentation. Regular definition we'll see first. Then next we'll see transition diagram. Next we'll see how to differentiate reserved words and identifiers. First, in order to define the regular definition, first let us see the regular definition of if-else statement. Suppose we will take if-else statement. How we can define the statement means statements. First we will be having only if, simple if statement. So statement, then arrow, then if is a keyword, then expression, then statement. We know that, for example, if a greater than 10, then statement printf something. Then if else statement means or the statement may be if, expression, then statement, else statement. If it is condition is true, one part, otherwise another part will be executed, or the statement may be an epsilon. Then expression we know it's a relational expression. For example, we may give x greater than 10. So that is the term relational operator, any relational less than, greater than, equal to or anything term. Then or it may be a term. The term may be, we will give x greater than 10 means x is an identifier, or the 10 is a number. So it may be a ID or it is a number. Then next we will see the regular definition of identifiers. So what is the definition of identifier? Identifier, what is the rule for identifier means starts with a letter, that will be followed by letter or digits. So the identifier is defined as ID that defines letters followed by letter or digit any number of times. The letter single letter also identifier. X is an identifier. Then the letter how we can define? It may be any letter in the alphabet, maybe a capital A to Z or it may be a small a to Z. Digit is any one of the digits, that is 0 to 9 anything. Then next we will see the regular definition for unsigned number. So unsigned number means all we know, it includes whole number, decimal number, it includes number with exponent. So the number is defined as digits, some digits, one or more digits. That is a whole number. That will be followed by dot digits means that is a decimal number. So question mark indicates one or more, at least one digit should be there. That will be followed by exponentiation. The number will, suppose for example 45e 10 will give means the exponent part will come. Then we will include plus or minus, it is optional. Then digits we can define, so one or more digits. The digit already we know that. This is a regular definition for relational operator means we know that there are 6 relational operators: less than, greater than, less than or equal to, greater than or equal to, not equal to. This is a regular definition for delimiters. Delimiters all we know, it may be blank space or new line or tab. At least one time it should exist, that's why we have used plus. So this thing already we have seen. So keywords, that is no attribute values. For white space character also no token as well as no attribute, but it will be stripped by the compiler. And then if any identifier is there means the attribute value is taken, pointed to symbol table entry. Number also that value should be taken. And for example, relational operator less than will take means a token name is RELOP, relational operator, and the attribute value taken is LT. Less than or equal to means LE, equal to means EQ, and so on. Next, this is a regular definition. So you may get a question in the university exam. Either it may be a regular definition of identifier, or it may be relational, or it may be an unsigned number. This is a very, very important question. The transition diagram next we'll see. So what is meant by transition diagram? So already we know the diagram consists of states and edges. So here what is the need for transition diagram? In the diagrammatic representation of patterns is called as a transition diagram. Already pattern we have represented with a regular expression. The same thing we are representing with the diagram. So here nodes or circles represent the states, and edges it's directed from one state to another, labeled by symbol. Okay. So then now we will see the transition diagram for relational operator. Already we know we have 8 relational operators. So we are having 8 relational operators, so that will be represented as 6 relational operators in that. So they are having 6 final states. So start, with one state, then 0 to 1 less than, it will read the symbol less than, then it will read the symbol equal to means it will be recognized as a token less than or equal to, then less than greater than, it will be not equal to, then less than, after less than it will recognize any other character. For example, 5 x greater than 10, then any other letter means it will recognize as a token less than. So it has to go one step back, then it will recognize that as a less than. Again backtracking, that is represented with star. Then next is equal to, it is a equal to operation, it will return the value equal to, and but less than, greater than or equal to, this is another token it will return, and then greater than also, after recognizing going one step back, it will return the value greater than. Then next we will see the transition diagram for identifier. We know that it will start station, then first it will be letter followed by letter or digit. This represents a loop that indicates 0 or more times. Then that will be followed by others, other than letter or digit, any special symbols, anything will be there. Then it will go one step back. The star indicates one step back, it will recognize that as an identifier. And then here return get token comma install id means whenever it will find a lexeme, that lexeme it will check in the symbol table. If it is already there means okay, otherwise return that value into token symbol table, and that will be installed into the symbol table. That is install id, the corresponding identifier will be installed into the symbol table. Then this is the transition diagram for unsigned number. Already we have seen that unsigned number means it includes whole number, then decimal number, and with exponentiation. So the whole number means it may be having one or more digits. So one digit followed by 0 or more, that will be the final state. Then decimal number means this flow it will come. Then with exponent, without plus or minus sign means it will go this flow, and with plus or minus sign it will go this flow. Then this is one of the important thing in the university exam. You may get a question as draw the transition diagram for relational operator or unsigned number or identifier. Next we will see how to differentiate reserved words and identifiers in representing the flow chart. So already we know the flow chart, that is a transition diagram of identifiers. So that will be represented with, it starts with letter followed by letter or digit. Suppose we will take the keyword if it will come with letter F, again it is a letter, then it is space. So that will be recognized as identifier? No, but if is a symbol word, a reserved word. So now to differentiate letter reserved words and identifiers, we have two methods. One method is, first what we will do means, in the starting of the lexicon analyzer phase itself, all the reserved words will be installed into the symbol table. Whenever any lexeme is identified over there, it will be checked with the symbol table. If already it is there, means that represents a reserved word. Otherwise, it will be recognized as a identifier. Second option is, we can create a separate transition diagram for each keyword. For example, then this is a transition diagram. Each state represents one letter, start, then T, H, E, N. After that, other than that letter, any other digits or special characters, anything will be recognized. Then it will return the keyword then. Same thing we can draw the transition diagram for other keywords. If means it will come start, I, F, then non-letter or digit. So only it will contain 1, 2, 3, 4 states it will come. Always we know this is starting state, ending state. Ending state will be represented by double circle. Starting state will be represented with start label. Okay, the star indicates backtrack. So suppose it will identify after then there is some space or something, it will go back one step, then it will recognize this as a keyword. Okay, so everyone understood about the how to draw regular definition, how to draw transition diagram for tokens, and as well as regular definitions. Thank you.